Okay, welcome. This is Gateway 2, Living with Tectonic Hazards. We're looking at associated landforms with plate boundaries. So before we start, please remember this is the second part. So we are zooming in and looking at the specific landforms and these plate boundaries. So what you see here is actually a photo of the Himalayan mountain range. The Himalayan mountain range, as we studied in Gateway 1, is a four mountain range, okay, formed by the Eurasian plate compressing against the Indian plate. Key to the concept of four mountain formation is the idea of compressional force. So when you have convergence between plate boundaries, compression against the two plates will force whatever is in the middle, whether you have sediments or you have a less dense layer that will not subduct. In the case, most of the time, is the continental plate. You will have folding forming. Note that for compressional force landforms, your synclines are your downward area and your anticlines are the top of the fold. So these are important terms that you need to know to describe folding. Now, this is a diagram of a map of where you will find four mountains distributed across the planet. Important for distribution question type, you need to talk about the direction of flow in terms of cardinal points. You need to talk about the type of plates that are found at these particular areas that will cause the four mountains to form. It is important to note that all these are formed at convergent plate boundaries or destructive plate boundaries. They can be formed from continental or continental oceanic plate boundaries. The other type of landform that we're going to look at is landforms that are formed through tensional force. Tensional force means you're pulling it apart. So it's forces that are pulling the plate apart and forming fractures that will occur as a result of this movement. So there are two types of landforms that you will learn that are a resultant of tensional force. One is your rift valley, the other one is your block mountain. So within tensional force, you are only looking at these two particular types of landforms. So what you see here is actually a diagram for formation of a rift valley. So important thing to note, if you are drawing this diagram, you need to have at least two diagrams together showing that tensional force will result in the fractures, the normal force forming. Further tensional force will result in the middle area subducting downwards or sinking downwards and forming a rift valley. Key to this diagram is the idea of tensional force pulling the plate apart, forming fractures. So think about it, if you're pulling a piece of rubber band along the two sides, it will snap, it will form a fracture. The piece in the middle will sink down and the overall shape is a depression. It will look like a rift valley. Now for a block mountain, we are still looking at tensional force forming the block mountain. So similarly, the plate is being pulled apart from the sides. You still have fractures that form, normal faulting occurs. But now the pieces that are by the side are subsiding downwards, leaving the middle blocks behind. So the ones that are left behind now form a sort of a raised platform, which is your block mountain. Note, this doesn't mean the block mountain is pushed upwards. The block mountain is simply left behind its original place. The resultant perceived elevation is as a result of the sinking of the rift valleys by the side of the block mountain. So once again, this is tensional force. This is the final diagram for tensional force, formation of block mountains. Now, as with our folding features earlier on, your tensional features can also be displayed out on the map in terms of distribution. Although we have not seen questions that seek to describe distribution of such landforms, it is not impossible. The answering technique is the same as answering for four mountains. You talk about it in terms of distribution and in terms of the plates. So we've come to the end of this very small segment on rift valleys and four mountains. Hopefully gives you a quick refresher